Hey guys, so this is the third or rather fourth instructional video, depending on if you count the optional video. This is on types of reactions for the second assignment of Unit 9. So here is my joke of the day. Unfortunately, I'm not there to hear your laughter. Let's see if I can move this. Okay, so this is on the 5 types of chemical reactions. So here are the 5 types. We have synthesis, decomposition, displacement, also sometimes called replacement, double displacement or double replacement, and then combustion. Okay, so some things that we've already talked about, but just as a reminder, so chemical equations are symbolic representations of a chemical reaction. Reactants are things we start with, and these are always on the left of the arrow. This is our arrow. This is called yielding. And then our products, which is what we end with, and that's on the right. So these are our reactants here, and this is our product. And here, this is our reactant here, and these are our products. And the arrow separates reactants from products. So normally I'd ask you, what do you think the word decomposition means? And hopefully you guys have some experience with the word of decomposition. And usually I get people who say, well, it means like to break down. And that's exactly what decomposition is. So if we look at these examples, the 2 equations on the left here are decompositions, and the 2 on the right are synthesis reactions. So what is the difference if you take a look at these 2? What is the difference between the decomposition versus the synthesis reactions? And usually I'll get someone to raise their hand and say, well, this one has one thing that's breaking down into multiple things, right? One thing breaking down into multiple things being separated by a plus sign. And this one has 2 things becoming one thing. Again, 2 things adding and making one thing. So synthesis is to synthesize, to make one thing, and decomposition is one thing breaking down into multiple things. So then looking at these, which of these below do you think might be a decomposition reaction? Well, hopefully you're going to say this one because you have one thing and it's breaking down into multiple things. So here's where I'd say, okay, guys, let's take some notes on decomposition, synthesis, single replacement, double replacement, and combustion. Okay, so first let's take a look at synthesis. And I just said it's 2 or more reactants combining to form one product. And here's the general form: A plus B makes AB, or yields AB. And here's an example: H2 plus O2 makes H2O, makes water. Okay, so 2 or more things adding up to make one product. It has to be just one product, okay? So multiple things making one product. That is a synthesis reaction, okay? Next, let's take a look at decomposition. Decomposition is the opposite of synthesis. It's though you take it and you switch the arrow around. So if you turn this arrow around, you would get a decomposition reaction. And here we have one thing making multiple things, breaking down into multiple things. So it's the opposite of synthesis, making 2 or more products. It has to be one thing, so one whole thing, breaking down into 2 or more things. Okay? Now, so here's the opposite general form: AB makes A plus B. And here's an example. We've got KCl, and it doesn't matter how many of them you have. You could have 100 KCl's, but you have KCl as the one thing. You don't have KCl plus H2O or something like that. Okay, and then it's breaking down into K and Cl2. All right, the next we have is single replacement and double replacement, sometimes called displacement. Doesn't matter what you call it. This is the trickiest one for students, determining the difference between single replacement and double replacement. Okay, so listen carefully. Single replacement is one element replaces another element in a compound. All right, so let's look at the pictures here and the examples. Here we have a compound and an element, or a single pair. That's why we get the word single. So we have one thing, it's going to bump out one of these things, and now we're going to get a new a new lone, okay, a new single, all right? So here we have iron and copper sulfate, copper 2 sulfate, and now this iron is going to bump out the copper, and now the copper's alone. But in single replacement, there is a single and a compound, making a single and a compound, okay? In double, so here's a picture of that, all right? Here's this one lone guy, and here's a couple, and now this guy is going to bump out this guy, and now we have a new couple, and poor Frank, okay? A single replacement, you start with a single and you end with a single, okay? In double replacement, everybody's a compound, okay? You have this compound and this compound, and everybody's going to switch around, and you have two new compounds. So in a single, okay, this would not be a compound, or this would not be a compound. Only one of them would be a compound. In a double replacement, both are compounds. That is the difference. Okay, so you might want to rewatch that again because that's what students get wrong all the time. So here's an example. This is a compound. This is a compound. Everybody's breaking apart and making two new compounds, but everybody's a compound. There are no singles here. Okay, so this is double replacement or double displacement. Again, everybody's in a relationship, then everybody breaks up and makes new relationships. Okay, all right, last type is combustion. And we already kind of talked about combustion in the balancing. It's a hydrocarbon. It just means carbons with hydrogens. It's going to react with O2, and it's going to yield carbon dioxide and water. So general form, we have X and Y's here because it could be 6 and 12 or 1 and 2 or 3 and 80 or whatever, okay? But it always is some type of hydrocarbon plus O2 makes CO2 and H2O. It has to be that exact thing. Okay, the only time that it's slightly different is sometimes there's an oxygen on this hydrocarbon, and that's okay. But if you don't have plus O2 and it's making CO2 and H2O, then you don't have a combustion reaction. You've got something else. That's very important because students get messed up with that all the time. All right, so now let's practice. Identify which reactions are synthesis and which are decomposition. So let me pull up my little laser pointer. Okay, so here we have two things making one thing. So this is synthesis. Next one, same thing, two things building up to one thing, that's synthesis again. This one, we have one thing breaking down into multiple things, that's decomposition. One thing breaking down into multiple things, decomposition. This one, two things making one thing, that's synthesis. And one thing breaking down into two things, that's decomposition. All right, now let's try single replacement or displacement versus double or combustion. All right, so here we have HBr as a compound, Cl2 is an element. So even though there's two of them, that's still a single. We're going to call that a single, making a new compound and a new single. So this is single replacement. Number one, single replacement. Number two, we have a single and a compound, making a new compound and a new single. Again, single replacement. Number three, we have a compound and a compound, making a new compound and a new compound. That's double replacement. There are no singles in this entire thing. So that's double replacement. Okay, here we have a compound, NiO, and a single, making a new compound and a new single. That's single replacement. Okay. Here we have CH2O. This is a hydrocarbon plus O2. There's a hint, making water and carbon dioxide. This is a combustion reaction. Last one, you can ignore this AQ and G. It just means it's dissolved in water. This means it's a gas. This means it's a solid. And this means it's a liquid. It's not really important for right now. This is a compound, MgOH2. That's a compound. This is a compound, making a new compound and a new compound. This is double replacement or double displacement. Okay. All right. Now these can be any of the five. So take a look, pause the video, see if you can predict, and then I will give you the answers. So this first one is going to be synthesis. The second one is going to be decomposition. This third one is going to be single replacement because we have a single and a compound making a new compound and a new single. This one is double replacement because everybody's a compound. This one's going to be synthesis, two things making one. This, while it kind of looks like a combustion reaction, it has most of the components. It's not, because it doesn't say plus O2, and also the products are on the wrong side. So this is actually going to be a synthesis reaction. You've got two things making one thing. That's synthesis. Here we have single replacement. Here we have synthesis again. Oh, I see that that is a repeat. Lovely. Here, again, it almost looks like combustion, but you can't have plus OH and make fire. A fire has to have oxygen in order for it to combust. So this is just going to be a double replacement. Compound, compound, making new compound and new compound. So it almost is a combustion, but it's not because it doesn't have oxygen, O2. Again, this one is a double replacement or double displacement. All right, so hopefully you guys are good with this. And if you have any questions, let me know. But there are only 5 things, and just practice that. Good luck.